Okay, in this video I'm going to show you a short form for electron configurations and energy level diagrams that's going to let us focus, instead of on the entire electron configuration, on the electron configuration that is going to be important for the chemical bonding. So to do this as an example, we're going to use neutral iron. Iron has an atomic number of 26, and so just make sure that's true. Yeah, it's 26. So we're going to be dealing with iron 26, as in 26 protons, and we're going to be assuming it's neutral, so we'll be dealing with 26 electrons. So the normal electron configuration is that it would be 1s2, 2s2, 2p6. If you don't know where this is coming from, you can go back to previous videos where I talked about how to make electron configurations. 3s2, 3p6. Here we hit the weird spot where it goes 4s2 instead, and 3d. Now let's go 2, 4, 10, 12, 18, 20. So I need 6 more in that D shell. The important parts of this from a bonding perspective are these electrons up here. These electrons are the ones that other atoms will first see when they want to make a bond, and then some funny stuff can happen with these ones to allow it to become multivalent, right? So those are really the critical ones that we're interested in. So when we want to make a short form for this, what we want to do is abbreviate all of this. If we look at this, then we can recognize that that is the electron configuration that is associated with the noble gas argon, Ar. So if we want to focus, and if we think about it, the reason that these are the ones that are possible for bonding is argon itself would be super stable, so anything argon and below is certainly not going to be available for any sort of bonding. So if we want to, we can abbreviate all of that section with big square brackets, not capital A, capital R, just capital A, lowercase r, the chemical symbol for argon, and then we can put the remainder of the electron configuration like that. So the way we come up with our short form is we abbreviate, or sorry, not abbreviate, well, whatever. We abbreviate by using the part that corresponds to the last noble gas we passed. So we passed argon in making this, so we can just take all that part, call it argon, and then we have the rest of our electron configuration. We can do the same thing with an energy level diagram, where we can convert what was 1s, 2s, 2p, 3s, 3p, and then we get to our meaningful part, 1s, 2s, 2p, 3s, 3p, 4s. We get to our meaningful part here, where bonding might actually happen. One more. 1, 1, 1, 1, and then double. And we can say, so this is the part that could participate in bonding. So we can take this part and abbreviate it with argon similarly. So this time we just put it below, and then we would start with 4s and then 3d. And this is a nice abbreviation technique because it allows us to think about the parts of the atom, or the electrons in the atom, that are available for bonding or might be involved in bonding, while simplifying the part that will not be involved in bonding by using a short form.